Okay, so professionally, I mean, I teach physics, of course, but professionally, my research is not so much physics anymore. About 15 years ago or so, I started collaborating with a plant physiologist. And for all this time, he and I have been working on a problem of how stomata on the surface of a leaf do what they do. Stomata are little microscopic pores on the surface of the leaf that open and close, and they open and close in response to many different environmental inputs, like, for example, light intensity, temperature, carbon dioxide level, and so forth. And in the plant physiology community, it's widely believed that stomata on the surface of a leaf do this. They open and close independently of each other. And the reason that they open and close is to try to take in as much carbon dioxide from the air as they possibly can while limiting water loss due to water evaporation. Well, the only reason I got interested in this in the first place was that my colleague sent me a movie of stomata opening and closing during a day in which they were doing experiments. And the opening and closing produced patches. Each patch might have maybe 100 to 1,000 stomata, all behaving the same way, adjacent to another patch where they're behaving in a different way. And during the day, these patches would change shape, move around, collide with each other, and do very interesting things. And I recognized that the patterns that you could see on the surface of the leaf were very similar to patterns that I have been studying in what are called distributed computational networks. A distributed computational network is made up of a bunch of elementary processing units, little maybe electronic devices that have some functionality, but they are wired to each other over short distances and can influence each other's internal behavior, internal states. And as a result of that, depending on how they swap information with each other, the whole network of these processing units can solve problems that no one processing unit even knows about. And I thought, well, maybe these stomata are like processing units. Maybe they're talking to each other, and when they talk to each other, they're solving this problem of carbon dioxide and water in a sophisticated network way that is different from how they would behave if they were not talking to each other. And that's what I've been studying for 15 years.
That's awesome.